Okay, we just got through expanding binomials, and this is the result of our work. And now what we're going to do is I'm going to write this down and see if I can see some kind of pattern with these numbers. We already saw a pattern with these exponents, with the x's and the y's, but look at these numbers. I've got 2, I've got 3, 3, I've got 4, 6, 4. I can see some symmetries here, so I see some symmetries with the numbers. So I'm going to write them down, and I'm going to actually begin with x plus y to the 0, just to make it consistent starting with 0. And anything to the 0 power is 1, so that's just going to be 1. And then x plus y to the first power is just 1x plus 1y. So I put the leading coefficients. We don't usually write the 1, so we just write the x squared, but I wrote them down just for the purposes of seeing how the Pascal's triangle is going to work. So this was x plus y to the first power, 1x and 1y, and x plus y to the 0 just happens to be 1. And then x plus y squared, if you go back and review what we did in the last video, we got x plus y squared was this, x squared plus 2xy plus y squared. So I wrote that down and expanded it out. I spread it out a little bit, I should say. X squared plus 2xy plus y squared. And then when we did the cubic, we got x cubed, 3x squared y, 3xy squared, and y to the third. So I wrote that out here. And then the fourth, when we expanded that out, we got x to the fourth, 4x cubed y, 6x squared y squared, 4x y cubed, and y to the fourth. So I wrote that down here. Kind of lined them up to form a triangle. And finally, when we did the x plus y to the fifth, you can see these are the terms we got from our expanding binomials video. And we had x to the fifth, and we actually had 6 terms. 1, 2, 3, 4, 5, 6. And when we had x to the fourth, we had 5 terms, 1 more term. Okay. And we expand this out. Now look at how these numbers work. Well, the outside numbers are always 1. And then we've got 2, but notice if you take 1 plus 1, you get 2. If you take 1 plus 2, you get 3. If you take 2 plus 1, you get 3. Pretty interesting, right? If you get 1 plus 3, you get 4. 3 plus 3, you get 6. 3 plus 1, you get 4. 1 plus 4, you get 5. 4 plus 6, you get 10. 6 plus 4, you get 10. 4 plus 1, you get 5. So this is what Pascal probably observed, writing something like this. So using these exponents as rows, he would call this row 0, row 1, row 2, row 3, row 4, and row 5, and you notice how these match up. And he just wrote the triangle without all the x's and y's. And this was Pascal's triangle. And all I did was I transferred my 1's from up here. These are your 1's. And then these are your numbers, 2, 3, 3, 4, 6, 4, and 7. And in each case, if you line them up right, 1 plus 1 is 2, 1 plus 2 is 3, or 2 plus 1 is 3, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and that's row 5. Row 6, 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, 5 plus 1 is 6, and that's row 6. Row 7, and notice we also happen to have a 7 there. 1 plus 6 is 7. 6 plus 15 is 21, 15 plus 20 is 35, 20 plus 15 is 35, 15 plus 6 is 21, 6 plus 1 is 7. Then go down to row 8. And again, each row is the expansion of the binomial to that power. So this is x plus y to the 0, x plus y to the first, second, third, fourth, fifth, sixth, seventh. So these are how we get the numbers. We already saw a pattern with the exponents. The exponents are starting with this and descending 5, 4, 3, 2, 1, 0 in x, and ascending in y. Y to the 0, y to the first, y to the second, y to the third, y to the fourth, y to the fifth. But these numbers are a little tricky. So Pascal noticed these nice little patterns that when we add these two numbers, we get the number below. So he came up with his famous triangle. And then I went out to row 8 here. 1 plus 7 is 8. 7 plus 21 is 28. 21 plus 35 is 56. 35 plus 35 is 70. 35 plus 21 is 56. 21 plus 27 is 28. And 7 plus 1 is 8. All right. And we can take it one more. We can do the next row, row 9. What's 1 plus 8? 9. What's 8 plus 28? Well, 28, 29, 36. What's 28 plus 56? Well, 8 plus 6 is 14, so that's 64, 74, 84. 56 plus 70, well, 5 plus 7 is 12, so it's 126. And then 7 plus 5 is 12 again, so we have another 126. And then 56 plus 28 is the same, so it goes back. It's symmetrical, 84, 36, 9, and we're done. So it's very symmetrical. These four look like these. And there you go. So that's Pascal's triangle, and that's how we determine the coefficients for our various expansions. And again, you can see over here, if I want to expand x plus y to the 5th, I've got my exponents, 5, 4, 3, 2, 1, none for x, and no y's, 1, 2, 3, 4, 5, y to the 5th powers. And then my numbers come from row 5 of Pascal's triangle, 5, 10, 10, 5, 5, 10, 10, 5. And the outside numbers are always 1. So now you can expand any of these binomials as far as you want, as long as you know Pascal's triangle.